Alright, now we're going to talk about vertical asymptotes, which actually we've already been talking about this, and everything I'm going to say is actually something you have already heard me mention. But as it states, vertical asymptotes occur at any value that makes the denominator equal 0, as long as it does not also make the numerator equal 0. So, vertical asymptotes are only at values that make your denominator equal 0. If it causes top and bottom both to equal 0, then that's actually where you have a hole and not a vertical asymptote. Alright, so first one here for us to determine the vertical asymptote. Start with your denominator. You always start with your denominator when you're doing vertical asymptotes. So I'm going to take the x squared plus 5x and set it equal to 0, because that's what I want to know. What causes my denominator to equal 0? This will need to be factored. You have a common factor of x. Okay, so when I solve this, of course this would, the first factor being x would give me x equals 0. My second factor of x plus 5 would give me x equal negative 5. Now these right now you can only just refer to as possible vertical asymptotes, because now what you've got to do is take them and check to see what happens in your numerator. So if I were to substitute 0 in, 0 cubed is 0, so this gives me 0 on the top and the bottom, which means this is a whole. Okay, negative 5 is not going to cause your numerator to equal 0, only your denominator, so this would be a vertical asymptote. Now when you're checking your answer, they're not going to tell you that x equals 0 is a whole. They're just not going to have that written in the list of answers, because the only thing you're asked about is vertical asymptotes. So the only thing you will see expressed as your answer is just x equal negative 5. Okay, next one. I'm not doing this any different. I'm just going through this one actually because it has a different type of factoring that I just want to refresh your memory with. Again, start with your denominator. And set it equal to 0. Now this having the 4 terms in it, your factoring is the grouping process. Of course, this is where you group the first 2 together. And then you group the last 2 together. Of course, you can group it differently sometimes, but that's typically the order in which you do that in. Okay, these 2 have an x squared in common. Now, these 2 don't have anything in common, but you still have to express that you've taken something out. And actually, I don't want it to be any different, because the thing about grouping is when you get to this step, you need these 2 to be exactly the same. So this is already what I want it to be because it matches this one. So the only thing I can take out that doesn't change, it's just a positive 1. But you do have to put that positive 1 there. Okay, so then you're going to pull out the x plus 2. And you're left here with x squared and left here with positive 1. Okay, so now you set each of these equal to 0. So I get negative 2. Now in solving this one, you actually end up with positive or negative I. When you're talking about holes being on your graph, vertical asymptotes being on your graph, that only involves real numbers, because your coordinate system here is not going to include imaginary values. So like in this case, you just don't get anything from it. So my only possible vertical asymptote's at negative 2. But I need to take this, substitute it back in, which actually is going to give me 0 on the top. So I get 0 top and bottom, which means this is not a vertical asymptote, this is a whole. So the back of the book would just simply say no vertical asymptotes in this case.